Okay, boys and girls, ladies and gentlemen, welcome to this maths presentation. Is there anyone thinking of studying maths? Yes. Is anyone thinking that maths is hard and you by no means want to study maths? No? Okay. So there are some doubts that I hope I will eliminate. So I want to show you that math is actually easier than real life, and it can be also fun. So I hope I give you an idea what geometry is, so you can go to some person on the street and just tell them. So anyone can think what is that? Geometry. You hear this word very early. You go in the garden and you play with some figures and. Then you go to school and solve some complicated problems. And then you get scared because the problems get insanely complicated, exponentially very quickly, right? And by the time the problems become three-dimensional, dropped and they're four-dimensional. Okay, so but coming back, so what is geometry? Okay, so let me tell you. Let me start playing a little bit. So I'm going to show you this, right? That triangle, right? And I'm going to draw another one. You think they're equal? No? Why not? Well, maybe it's the quality of drawing, but you have to think. You have to use your imagination and remove all the necessary details. That's how we think in maths and how we learn to think in maths. You live in idealized world. The real world is very hard, very complicated, but the ideal world is actually much easier. The ideal world, I hope these two triangles are. Okay, well, you can imagine. Right? Why it is the same? Because you can just, if you have some powerful tool and you can cut it out of the blackboard, you can simply move it here and put it right there. Okay? So what does that mean? There is a translation. That's a transformation called translation. That's what we call it in math. And that's why right now I'm going to draw another triangle, and I'm going to draw, would you say they're equal? They still say they're equal, but there is no translation to put this here. So what happened? Why is still they're equal? Some other transformation. Rotation. You can rotate. So you increase your tools. You change the problem. You enlarge the possibilities to flex, and now they're equal. Okay? So that means that we change our geometry. Before, the geometry only allows us to translate, now it allows us to rotate. Now next step. We have one triangle like this, and we have one very tall. What do you think now? Are they equal? Well, maybe opinions will divide because it's not a correct question. Right? Equal is appealing to what we call equal. Right? It appeals to the transformation that we allow. And now you see how to get from here to there. You need to be able to flex. So you have to imagine that the triangle is made from some flexible stuff, and you just pull it. You put it here first, and then you grab it with all force, and you just drag it until it hits, until that surface hits. And you see that, but you allow more flexibility. Now, this is called stretching, and it's actually very powerful. You can get, it's a very simple thing to stretch, but you can get completely new things by doing that. So let me show you where. Okay, everybody knows circle. Right, that's something you can roll. Right? Now this is a circle. Now what is that? Oh, my drawing again. My drawing has a flaw, but you have to use your imagination and move to the ideal world where this is a perfect picture. Right? So, anyone knows how is that called? Oh. An egg? An ellipse, right. Ellipse. Okay? Right. So what is an ellipse? That's just a circle. Right. And this is ellipse. What is that? That's not an ellipse. Even with your best imagination, you wouldn't believe me that this is an ellipse. Right? Because here the quality of drawing decreases dramatically. So why is it ellipse? And why is it, how do you get the ellipse? Huh? Home. Okay, well that's one way. Yeah, so you have to go to the three space, you have to go to home, and cut it, and then you. How much? It's true, but it's more complicated. Or can you get it easily from the circle? Can you say that the circle is equal to ellipse in some other geometry? Geometry where we allow stretching. Like here, like we said that this triangle is equal to that triangle. Once we allow stretching, the same can happen here. So you just imagine you take your circle and it's flexible and you stretch it, grab it north and south pole, and stretch it and it becomes ellipse. And mathematically, it's not just, now this was a game, but there's also some power behind that. It gives you power to calculate and to describe it precisely. Also, if you want to draw it on computer, of course computer will do it much better. So you think, why should I do it? I can just draw a picture on computer. But somebody has to write program. He has to come up with an algorithm. There are several stages before computer is ready to write. Of course, somebody has to design computer, but suppose it's done. And somebody has to write algorithm, and somebody has to put algorithm in the program, and then the program will do it. So, how to get this? Well, we are at the stage where we have no program. We have to write it. So here it is. Here the circle. Now, everybody remembers what's the equation for the circle. If you want to get precise, we have to write it. So the equation is like that: x squared plus y squared is 1. Now, if you listen carefully, how would you write the equation for ellipse? You would stretch the equation. How you stretch the equation? You simply put a factor. Instead of x plus y, you put x over 2 squared plus y squared. That means you stretch x, you scale it, you factor. Like when you change the measurement, you scale it. Like when you go from meters, you transfer meters to centimeters, you scale, you multiply by the same factor. Same kind of scale. And that's what you get in the equation. So that is the power of the change of coordinates, or the power of transformation. And that is exactly what geometry is. The geometry is the study of properties that and how they change under whether things are equal. Okay, now this was still maybe a little bit abstract and irrelevant. Now let's go to some more interesting problem. Oh, you all have smartphones. Anyone? No, have smartphones? Okay, so you know that in smartphone you can write. You have some text recognition, right? You can write short message by hand. You can have letter. Of course, you can type it, but sometimes you are drunk or you can't. It's hard to hit the right button, or you are in a nasty bus that drives very bumpy on a bumpy road. So you start going into one direction, but by the time your finger ends at the smartphone, it ends at the wrong button. So instead just try to write. So you write and you write a letter A, but maybe you write it like this. Maybe you write it like this. You want this all letters to be recognized as A. So you want to declare them equal. And again, you come to the same problem. Why these A's are equal? Do you still call it A? What about this? Do you call it A? Or maybe this way. Well, you just turn your smartphone and you still want to write A. So why would you not allow this A? Still A, right? After rotation. So you want to use some flexibility. You have to describe flexibility. That's part of your problem. Once you describe it, you know exactly what it means to be equal. And that means you have some transformation from this A to that A, but you see that the transformation is more complicated. It's not just translation or rotation. You need some stretching, or you need some something else. Maybe if you are completely drunk, the A will look like this. And there is some rules that transformation has to follow. So you can't just do. You see that A, well, you can make this A to B. Just try to pull these two ends together and then you get B. No, you don't want that. You want to separate B from A. There is a problem of recognition, and you have to prescribe which transformations I allow. And this kind of transformations, also you don't want to destroy corners. You want still to have the corner. You don't want this to be A. Maybe sometimes. Depends, but usually you don't. So you want to see that corner, and that puts restriction on transformation. So you have some class of transformation. Send it here. Okay? So how do we do it? We need to, we describe the class of transformations. That's the main point. What are the transformations? They're called smooth transformations. They don't break lines into commas. This is not allowed. Something that moves smoothly. Okay, if you're courageous enough and come to maths, you will learn what is exactly. Okay, that's smooth as that. There is some powerful language out of this. Okay, now that is still relatively simple problem. What is another idea? You have this. This is your A, or maybe you write a big one. You have space in your bus and nobody disturbs you, then you can write very big A. But if you are crammed and you just a little space, then you have to write it smaller. Still want it to be recognized the same. So there is some flexibility to expand, to stretch in both directions. And well, how would you do it? Just to give you some flavor. Well, you would use this transformation to measure. So you would stretch it and overlap. I would stretch it, and maybe it will not be perfect. It will fall maybe like that. You see, it's kind of overlapping, but not exactly. Well, you can introduce some distance, and you measure the distance between these two patterns, and you allow some critical distance, and you want it to be sufficiently small. So, if the picture gets rougher, as it gets rougher and rougher, this distance between these two A's bigger, and then you can imagine at some moment you get this A, and then you get something like this, and one. So there is some mathematics behind, but it's actually very simple. It's much easier. So once you translate into maths, the problem becomes exact and it becomes complete. Complete means everything is there. Like here, this problem is complete. I tell you that you're only allowed to translate So then you just tell me you can translate this triangle into that triangle, but not this triangle into that triangle. See that it's all there. So by doing maths, you also learn how to use it in the real world when you have to look for completeness. So what is important for your problem and what is not. Because if I just ask you, are the two equal, that's not complete. It will tell you the exact condition. It's like stating all the rules. That's what it's about. Okay, now we move to the more exciting problem, sound recognition. And actually it's quite, it's still fundamental, still very big challenge, and there's still a lot to do. So, where you find this problem? For instance, if you look, what is that? That's, I think that's an old century. The key, right? So what's the technology to be recognized when you come back to your home to be recognized as an authorized person to enter? So that's the technology. See how simple is that? And then you lose it, or it gets broken or damaged, and you're out of luck. You have to call somebody to help you, maybe in the middle of the night, maybe in the middle of the rain, maybe in the middle of snow, maybe in the middle of holiday, which is even worse because nobody comes. And that's it. So what's the more advanced technology? Well, let's say sound recognition, like your dog. The dog, I call it a perfect dog. So what is a model of a perfect dog? It's a dog who barks precisely at the right person. So the dog would not bark at you because you're authorized. The dog would bark at everyone else who is not authorized. It would not let anybody else come into your home. And how are you recognized? For instance, by the sound or by the smell. It's another aspect. So sound recognition means you just come, you say some hello, I'm here, and the door opens because the sound is recognized. Isn't it much better than this key? And then you don't have to worry to lose it, so you don't need this chain and all the other troubles. So maybe you are the hope of our future, and you will be the one who developed this technology. Of course, it has to be safe, secure, fully functional, and so on. But that's where the challenge. So, where is the problem? There is a very mathematical problem underlying. Because what is sound? What is your voice? The voice has some and can be described by some mathematical function. Right? Higher law, and there is some graph, we call it graph, right, in the background. So now there is this voice, there is this sound, and there is another sound. Maybe you got cold and you change your sound. So there is some transformation. Your sound became transformed, but you still want yourself to be recognized. So where will you be recognized when the two sounds are equal? You can't do the same problem. Except that the problem is now more complicated. So you see, the real life problem is actually much more complicated. It's a real life problem to explain what it means to be equal. But once you explain it, it becomes a mathematical problem, and that is actually very easy. Once you have an algorithm, once you have it complete, once you have all the settings, you can do it. For instance, here you can say this, there is a translation sending here to here. So obviously it's not good. But you can have also some deformation of the sound, and then you measure the distance, and that gives you some. Then you call to sound equal if the distance is small. So that's where also use geometry. Where geometry is your transformations. Take this sound into that sound, you compare and you measure. There is geometry and there is metric. You have to measure the distance. That's another value. That's it. And then if you can do it, then you can solve the problem. You take two sound and you have a pattern of the sound, what it should be. You have somebody come into your home, maybe you, maybe that person, and you compare. And the system is secure if it recognizes the bad person, or maybe the good person, but still, you never know. So, still somebody else who is not authorized, and it will perform the check, and the door will open precisely when it should. Wouldn't it be nice? Yes. Okay, so hopefully we will find a solution to this problem and make our future better. And hopefully you will also enjoy it. So part of doing maths is also to enjoy it, and it can be fun. The reason why some people get scared because maybe it's not explained well, or maybe sometimes you look at example and it's too complicated. So maths teach you to find the simplest possible example. And it happen to you that you read something, you want to try to learn something, and then there is an example. The example is just horrible. It has all kinds of features. And it's completely inappropriate. Maybe it's an interesting example, but for the feature that you study, for the problem, so then to find the simplest example is also studied. Okay? Are there any questions? Any suggestion? So I hope I showed you that maths can be simple, and if you like it, and hopefully you hope to see you again, maybe in maths, then I think